At the Eastern Space and Missile Center, a major turning point in our space program came in the late 1980s. After a general decline in the expendable launch vehicle industry as these boosters were being phased out in favor of the shuttle, a strong re-emphasis was placed upon unmanned launch operations. This heralded whole new generations of more powerful Titan, Atlas Centaur, and Delta launch vehicles. The Air Force and civilian space programs had been hard hit by the tragic loss of Challenger and its gallant crew in January 1986. This was followed by a Titan 34D booster failure at Vandenberg Air Force Base in April and a subsequent Delta failure at the Cape in May. In the aftermath of these mishaps, America lost its assured access to space for 17 months. While NASA proceeded to reorganize its space transportation system, an aggressive national recovery effort restored the powerful Titan 34D launch capability. In July 1986, Air Force Secretary Aldrich described the future Titan program.
This earlier decision will be augmented with new expendable launch vehicles, including the procuring of an additional 13 Titan 34D CELVs, which we now are calling Titan 4s. And the model of that particular vehicle as shown on this display is the one next to the shuttle. It's the one with a larger payload section, which is exactly the same size as the shuttle, and it can provide the same lift capacity as the shuttle.
A considerable backlog of payloads awaiting launch had developed, including important national security missions, as well as scientific and communications payloads. In addition to its current contract with Martin Marietta for the Titan IV, the Air Force established contracts with McDonnell Douglas and General Dynamics for the Delta II and Atlas II. By establishing agreements which allowed commercial launch operations, the Air Force took the lead in carrying out the President's order and a new public law designed to encourage the nation's unmanned launch vehicle industry. When the Navy's launch agenda for Trident I and II programs was considered, it was clear that the Eastern Space and Missile Center was gearing up for a launch rate not seen since the late 60s. As the Eastern Space and Missile Center's agency for all Department of Defense or DoD launch vehicles and spacecraft launched from Cape Canaveral and Kennedy Space Center, the 6555th Aerospace Test Group, or ASTG, was responsible for launch vehicle management, payload planning and processing, and online test operations. The 6555th's Spacecraft Division directed ground processing of all DoD satellite systems put into space from the Eastern Launch Site, including those carried aboard the Space Shuttle. They determined spacecraft readiness and provided the payload test director for each mission. Spacecraft Division also managed test facilities, such as the Shuttle Payload Integration Facility. In fiscal 1988, Spacecraft Division supported 2 classified Titan 34D missions and took part in Titan IV Pathfinder operations. It prepared 2 Navstar Global Positioning System satellites for future Delta launches and also determined cargo and support requirements for shuttle operations. The Network Operations Branch also directed the activation and checkout of the DoD Secure Voice System to be used on classified Titan and Space Shuttle missions.
Roger, RSO. We have the LSRO on the conference at this time. All range instrumentation is go for launch. Everything is fully mission capable.
The 6555th Titan Division managed all Titan 34Ds and Titan IVs, as well as all inertial upper stages used with various launch vehicles. This division also provided test launch controllers for each Titan mission and for shuttle missions involving DoD upper stages. During 1986 and 87, one of the division's most pressing concerns was the Titan and the IUS recovery program. This was a broad-based effort within Systems Command to revalidate the Titan 34D system following the Vandenberg launch failure in April 1986. A non-destructive X-ray facility at the Cape was a key element in the program. For the first time, This facility enabled the inspection of Titan and IUS solid rocket motors for flaws in the propellant, the restrictors, insulation, and potting compounds. Other kinds of non-destructive testing included ultrasonic examination, visual inspections, laser imaging, and thermography. The X-ray facility was built in autumn 1986, and by the summer of '87, the test program was completed. Titan 34D launch operations resumed in November 1987. The Titan division also supervised Martin Marietta's renovation of Launch Complex 41 and other Titan facilities before the launch of the first Titan IV. Complex 41 was turned over to Martin Marietta in July 1985, although real property accountability was retained by the Air Force. The refurbishment work began in January 1986. Through multi-year funding, Martin and its subcontractors were paid nearly $60 million to tear out, refurbish, or replace old structural, mechanical, and electrical systems. Martin, as the major contractor, hired 50 area subcontractors for the work on the complex's mobile service tower, the umbilical tower, and other facilities. Modifications to the solid motor assembly building began in November 1986 and were finished a few months later. Modifications to the vertical integration building began in March 1987 and were made through the end of the fiscal year. Work on both ground transfer equipment and off-site modifications, which began in September 1986, continued well into 1988. These modifications were designed in support of the newest member of the Titan family. The Titan IV vehicle featured a lengthened core, a 200-inch diameter payload fairing up to 86 feet long, and longer solid rocket motors. Currently, the solids are made up of 7 10-foot segments, but a new 3-segment solid rocket motor, the SRMU, will be introduced on later missions. The Titan IV has a payload bay comparable to the Space Shuttle, and with its improved thrust and Centaur upper stage, it will be able to boost a 10,000-pound payload into geosynchronous orbit. Processing of the first Titan IV hardware began at the Cape in January 1988. In late April, Martin turned the mobile service tower over to the Air Force, and Titan IV Pathfinder efforts continued through the end of the year. Parallel Titan IV design and testing operations were required in order to meet the launch schedule. Despite numerous engineering problems, test anomalies, poor weather, and a stubborn mobile service tower, the Pathfinder team overcame these obstacles, refined the launch system, and tested it rigorously before the first Titan IV was ready to fly.
7, 6,
The launch,
5,
June 14th, 1989,
3,
was a complete success.
1.
The Eastern Space and Missile Center also managed the Delta II launch pads at Complex 17 and the Atlas II launch pads at Complex 36. McDonnell Douglas and General Dynamics, as the respective contractors, were preparing these sites to support multi-year defense contracts for these new medium launch vehicles. 2 types of satellites were included: the Navstar GPS and the Defense Satellite Communication System, or DISCUS satellite. The contractors had also lined up other customers for commercial launches. Their people were working 12-hour shifts to refurbish and modify the launch pads for the taller, more powerful Atlas II and Delta II vehicles. Umbilical and mobile service towers at launch pads 17A and B were lengthened in 1987 and 88. Atlas Pad 36A had been idle since 1983, and work on 36A's towers began in 1989. Restoring it to service called for extensive corrosion control, a brand new umbilical tower, and modifications which increased the height of the mobile service tower by 40 feet. In preparation for an upsurge in medium launch vehicle operations in the early 1990s, The 65 55th Aerospace Test Group transferred 23 personnel to its new Medium Launch Vehicle Division on 1 June 1988. By September, the division expanded its horizons to include supervision of commercial Atlas and Delta II operations. Commercial Titan operations remained under supervision of the Titan Division. The Medium Launch Vehicle Division supervised the erection of the first Delta II vehicle, Delta 184. This was at Pad 17A on 2 November 1988. Carrying a Navstar GPS satellite, Delta 184 was successfully launched on 14 February 1989. An older version for the Delta 183 mission was erected at Pad 17B on 25 November 1988. Delta 183, with its Delta Star Space Defense Initiative payload, lifted off successfully on 24 March 1989. By the end of fiscal year 89, the Delta launch team successfully placed 2 more Navstar GPS satellites on orbit. This enabled the first operational test of the new satellite constellation. Global positioning satellites will be able to pinpoint the location of a receiver within 15 feet anywhere on Earth, calculate its speed within 10 miles an hour, and keep time within 1 nanosecond, a millionth of a second. McDonnell Douglas launched its first commercial Delta vehicle with a British broadcasting satellite aboard on August 27, 1989. Although the test group's reorganization helped ESMC to make the most of its manpower, the Eastern Space and Missile Center's commander remained concerned about the potentially serious manpower shortages that would arise from a greatly expanded workload in the 1990s. At the close of the 80s, the center was manned as well as any agency in the Air Force. However, only marginal manpower increases were expected in the 1990s, while the launch rate was expected to rise from a handful to roughly 40 per year. This projection evoked memories of the 1960s, when the center's workforce was about twice as large as it was expected to be during the early 1990s. The test group was already concentrating more of its effort at the launch system level. For routine subsystem supervision, it relied on contractors, but became more deeply involved whenever a problem surfaced or whenever hazardous tasks were conducted. The center's Directorate of Quality also placed greater emphasis on its inspectors' experience and initiative to keep the contractors on their toes. The problem of supervision was simplified by requiring the same quality standards for commercial and military vehicles. From the mid-80s onward, the Eastern Test Range was revitalized. Major overhauls of existing range equipment went side by side with necessary new procurements. A major new instrumentation facility, the Missile Tracking Annex, was built at Jonathan Dickinson State Park, about 95 miles south of Patrick. Larger and more sensitive telemetry antennas were purchased for the USNS Redstone. The Range Control Center was modernized, and an ambitious effort was underway to create a Test Operations Control Center, or TOCC, within a more fully automated range. Improvements were aimed at increasing the range's operational flexibility and reducing its manpower requirements without sacrificing reliability. This was a challenging task, given the age and condition of much of the range's instrumentation. This state-of-the-art control center for launch vehicle, ballistic missile, and on-orbit test operations was the leading improvement and modernization project of the late 80s. The TOCC will consolidate the functions of 3 Cape facilities under one roof: the Range Control Center, portions of the Communications Building, and the Central Computer Complex. The Operations Center will also handle computer software development, post-mission data processing, and technical analysis for each launch operation. In addition to an estimated $19 million for the TOCC building itself, related instrumentation worth more than $60 million would be installed. The groundbreaking was held in February 1989. If all went as planned, the Operations Control Center could be fully operational by the end of 1991. It was all part of a larger strategy to consolidate widely scattered assets, to reduce manpower and prepare downrange stations for remote station automation. In turn, remote station automation would link these assets to operators in the TOCC. This accomplished, the Test Operations Control Center would serve as a fully integrated nerve center for instrumentation throughout the range. Thus, the Cape, Jonathan Dickinson, Antigua, and Ascension would possess new or newly modified radar, telemetry, optics, and communication systems ready to operate under the remote station automation concept. This would link the Eastern Test Range to a global network of Navstar GPS satellites and with other centers. It'll enable the ETR to support simultaneous test operations worldwide. Between 1989 and 94, range automation consolidation projects would cost more than $114 million. Earlier modernization in fiscal 1988 included completion of work on the Melbourne Beach Remote Optical Tracking Instrument, the arrival of 3 distant object attitude measurement systems from the White Sands Missile Range, transition to the VAX-based Range Safety Display System, a contract for a broad beam command antenna at Jonathan Dickinson, a contract for a digital communications switching system, installation of the local area network system and the local online network system, plus various weather and timing improvements. The Eastern Space and Missile Center, with its launch facilities, instrumentation sites, and 10,000-mile test range, supported many different types of launch operations over the years, as its recent history records. During fiscal 1985 and 86, for example, the center supported 12 successful space shuttle missions, the ill-fated Challenger mission, 1 successful Titan 34D mission, 3 successful Atlas Centaur launches, 3 Delta missions, 1 of which was unsuccessful, 16 Poseidon launches and 15 Trident 1 launches conducted by the Navy off the coast, 9 Pershing 2 launches conducted by the Army from Complex 16, plus 7 British Chevaline submarine ballistic missile launches, and 5 successful and 2 unsuccessful Ariane missions launched by the European Space Agency from their French Guiana facilities. Range support was excellent, with a frequently outstanding instrumentation performance, and for the most part, data acquisition was limited only by launch vehicle performance, weather conditions, or flame attenuation during staging. While most 1985 and 86 launch operations went well, the loss of Challenger and its crew 73 seconds after liftoff in January 1986 halted operations on a tragic note. Colonel Edward A. O'Connor, the 6555th Aerospace Test Group's Director of Operations, was asked by NASA to coordinate the search and recovery effort pending establishment of an accident board. He continued as chief of the Search, Recovery, and Reconstruction Team under the auspices of NASA's STS-51L Data and Design Analysis Task Force. The shuttle recovery effort was one of the largest salvage operations in modern history, involving over 7,000 people from NASA, DoD, the Eastern Space and Missile Center, Tenant Search and Rescue Forces, the Coast Guard, Navy, and a considerable number of public and private interests. After 4 months of intensive work, the President's Commission reported that a failure in Challenger's right solid rocket booster, the aft field joint between the lower booster segments, caused the accident. Following the Commission's recommendations, the solid rocket boosters were thoroughly redesigned and tested before being approved for flight. Throughout an exhaustive 32-month-long recovery effort, many of the orbiter's major systems and components were sent back to their vendors for modification or refabrication. The next shuttle mission, STS-26, heralding our return to space, began when Discovery lifted off from Kennedy Space Center September 29, 1988. Navy Captain Rick Houck commanded a veteran crew of shuttle astronauts. Air Force Colonel Dick Covey was the pilot. The mission specialists were Mike Lounge, Marine Lieutenant Colonel Dave Hilmers, and George Pinky Nelson. In a highly successful 4-day mission, the crew launched NASA's second Tracking and Data Relay Satellite, or TDRS, and made a safe return to Earth at Edwards Air Force Base on October 3rd. 4 other shuttle missions were successfully launched in fiscal 1989. A total of 45 launches were conducted during fiscal 1987, including 2 Atlas Centaurs, 2 Deltas, 16 Pershings, 4 British Chevelines, 10 Poseidons, 5 Trident 1s, and the first 6 Navy Trident II test missiles successfully pad-launched from Complex 46. Range instrumentation also supported one Ariane 3 mission launched from Kourou, French Guiana. While range support was highly successful, destruct commands were required for 2 British Cheveline missiles in May 1987. In March, an Atlas Centaur AC-67 had been destroyed after lightning struck the vehicle at T+48 seconds. A Navy communications satellite, Flight Satcom F6, was also lost in that mission failure. There were 39 major launches in fiscal 1988, including 2 Titan 34D missions, 1 Space Defense Initiative experimental launch, the flight of STS-26, and 35 ballistic missile launches. 6 Ariane missions were supported by Ascension Island instrumentation, and range support was excellent for all missions. Destruct commands terminated 1 Trident 1 launch and 3 out of 9 Trident 2 flights. Other launches were extremely successful, including STS-26 and the highly complex Delta 181 Space Defense Initiative mission. The purpose of Delta 181 was to conduct multispectral signature experiments with its 2 deployable payloads. One consisted of a science package containing 8 test objects and 4 reference objects. The other was a package which would generate a missile plume. The second stage carried command and data handling modules. These would order experiments and then collect resulting data for real-time and post-flight transmission to ground stations. A tremendous amount of multispectral signature data was gathered via ultraviolet, infrared, radar, and laser sensors. As lead range, the ETR conducted tests ensuring that its worldwide network was prepared and Delta 181 ready to fly on February 8, 1988. The Delta's second stage was boosted into a 90 by 120 mile low Earth orbit, and experiments were completed during the first 7 orbits. Stage 2 then boosted itself to a 171 mile circular orbit, stabilized itself, and continued transmitting its data back to Earth stations. Delta 181 was one of the most complex programs in the history of the U.S. space program. There were 25 major launches in fiscal 1989, including the first Titan IV mission, the first 3 Delta II GPS missions, 2 Titan 34Ds and Delta 183, the first commercial Delta launch, the first commercial suborbital launch of E' Loft 1, and NASA's final Atlas Centaur mission. There were 4 Trident D5 pad launches, 3 Trident D5 submarine launches, 2 Poseidon and 2 Trident C4 launches, and 4 space shuttle missions. 8 Ariane missions were also supported by Ascension instrumentation. Although 2 of the Navy's D5 test missiles required destruct actions, other launches were successful, including the complex Delta 183 mission and 4 space shuttle missions.
Test group is go and you are cleared to launch.
While this report has touched on developments at the center from October 1984 through September 1989, other milestones will be presented in future reports. The Eastern Space and Missile Center, Eastern Test Range, Air Base Group, and Aerospace Test Group, serving America as part of the Air Force Systems Command.